opportunity to talk to you about biometrics. I know most of you already have attended a number of biometric courses, lectures, including in this particular course. So you're quite familiar with biometrics, but I'll just give you my perspective. And so I put the biometric recognition at edge. Basically, I'm going to mention a few difficult scenarios for biometric recognition where we need to make more progress. And since many of you are students, I thought it would be appropriate as well.
Dr. Jain, I wonder if your screen is not being shared.
Oh, let's see what happened here. Okay, share screen.
Yeah, we can see it now.
Okay, sorry. And so I primarily work in fingerprint recognition and face recognition. In fact, I started in fingerprint recognition almost 30 years ago when the only application was forensics and law enforcement. And the computer vision people didn't appreciate fingerprint recognition very much. They thought, well, isn't it a solved problem? And so fortunately, over the past 30 years, with the help of students like Arun and others, we have built a fairly strong research program in fingerprints because the whole field is available to us. Everybody thinks it's a solved problem. And I think pretty soon, this may be the case for other biometric modalities as well. Most of the attention currently is focused on face recognition, but even though frontal to frontal face recognition problem is solved, there are still many interesting challenges, which I will talk about. So I think it's very important to understand anybody who works in biometrics is what is the fundamental premise of biometrics. So in my opinion, there are two fundamental premises. Individuality, that is different individuals have different biometric feature values. So whether you are working on iris recognition, face recognition, fingerprint recognition, this is the starting point. Whether it is true or not, that's a different thing. But everybody starts out by, when they write a paper on biometrics, well, fingerprints are unique and they persist, but nobody cares as to whether it is true or not, or has anybody shown it. So individuality, different individuals have different biometric feature values. And in early 2000, the US Department of Justice asked for some research proposals to study this problem. And when they received the proposal and evaluated, they did not fund anyone, including ours, because they were worried about what will the findings be. What happens if the fingerprints are not, turns out mathematically to be unique? That is, there is a small probability, no matter how small, that my fingerprints may have close resemblance to Arun Ross's fingerprints. So but we decided, my former students, Sharat Pankanti, Salil Prabhakar, we said, let's just solve this problem anyway. And that was our first formal effort and on showing what is the likelihood or what is the probability that two different individuals will have sufficiently close similarity for fingerprints. And the second thing is permanence, right? I mean, that the recognition accuracy does not change over time. Because if the recognition accuracy changes over time, you have to either re-enroll the person or the biometric recognition is no good. So it is these two properties which result in a preference for biometrics over the PIN code or token and so on. So what we need in order to build a biometric recognition system is a measure which will give large similarity for different images of the same person. So that is, intra-person similarity is large, and small inter-person similarity. That is, this measure, similarity measure, should give small values for when I compare two different persons, whether they are identical twins or they are doppelgangers, as I show here. So In the case of these 2, 4, 5 images of this woman who has been arrested multiple times over a 10-year period, the first time she was arrested was January 1995, and the most recent arrest was February 2005. The state-of-the-art face recognition system has no problem in finding a high similarity value among these 5 photos. And this was not the case 5 or 10 years ago, where face recognition was in the early stages, and age-separated images caused a lot of problems for face recognition. But now it's not a problem, and later on, I will show you some more examples of this. So I think you may be aware of this notion of individuality and permanence, but you may not be aware what that is the starting point for designing any biometric system. So if you're thinking of saying, okay, forget about face, fingerprint, iris, I will choose some other modality. Well, first thing you should do is to look at its individuality and permanence. Now, it may be not necessarily for the whole world, but it may be just for the, let's just say, if we're talking about deploying a system in Israel, we can just think about a population of say 10 million, and that it's good for 10 million. In the case of India, where we have a national ID system with 1.5 billion gallery, either a single modality or a combination of modality should be able to satisfy that. So now I can progress the slide. Okay. Okay. So now we know about this individuality and permanence. The essence of biometrics, in fact, the essence of machine learning or essence of artificial intelligence is to compute the pairwise similarity. Given any 2 images, whether face, fingerprint, iris, or I may just give you 2 images, one of face, one of iris. The challenge is to find a representation and a similarity measure so I can compute a numerical similarity value. Look, this is, we are designing a machine recognition system. So the machine has to have some notion how to declare these 2 images as coming from the same face or from different faces. So that is the essence. So in this particular case, this is my former postdoc Kai. Left is his scanned driver license photo, and the right is his portrait image. And we need to be able to have a similarity measure, which will say high value for this. And indeed, a open source ArcFace will give you a value which is close to 0.7 on a scale of 0 to 1, where the threshold for 0.01% FAR is about 0.4. So it exceeds the threshold. That means the system will say these 2 images are of the same person. So the challenge in biometrics is, as the quality of these 2 images between which we are computing the similarity becomes poor and poor. If the quality is very high, it's a solved problem. If the quality is of medium quality, if the images are of medium quality, the problem is almost solved. But when you have a low quality video or a frame for the probe, and gallery is of high quality, starts becoming challenging. What if we compare a low quality video frame as probe to another low quality video frame in the gallery? That's a hard problem, all right? So this notion of similarity, essentially you can put your problem, is it easy, medium, hard in some qualitative scale. So please feel free to, I'll be happy if you ask me questions. Okay. So as I mentioned, the challenge is 2 challenges: a representation of the image, because we are not going to compare pixel values. If you look at these two images, if you start comparing pixels, even under the assumption they are of the same resolution, same size, it won't work, because the face is not defined by just a collection of pixels. There's some structure to the pixel arrangement. So that is why we need some high-level representation. And then once we have a representation, the similarity measure is governed by the representation. So So let's say before 10 years ago, all the machine learning, AI, or biometrics dealt with what is called the handcrafted features. That is using the domain knowledge. If we want to design a fingerprint recognition system for over 100 years, the fingerprint manual examination of fingerprints, and still now to this date relies on minutia points. So that's what I mean by handcrafted features. What about in the case of face recognition? Well, unlike fingerprint recognition, face recognition, there was no unique set of features which everybody agreed on, but typically people use the landmarks on the face, the corners of the eyes, nose, mouth, things like that, boundary of the face. And then once you define these handcrafted features, then you found some relationship between, you could have a graph structure, you could just represent them as a set of vectors. And then you have a learning algorithm. It used to be SVM or any other kind of technique, statistical technique to find a decision boundary. And then you do the prediction. Now, with the advent of the deep networks, which are not new. I mean, deep networks have been around for a long time. In 1980s, LeCun used convolutional neural network to do the digit recognition. But then, there was not enough data to train them. The processors were slow. And so it's resurgence of the deep neural networks. And the deep neural networks is nothing but multi-layered networks with some other bells and whistles on it. So now we have a situation where there is a joint learning of features and learning. So the joint learning of features and the decision rule. And that's, so now we have a black box. You just feed in the data and out comes the prediction. And so that's what everybody is adopting, except that deep networks are not always the best way to do it. You still need some domain knowledge. So when we say domain knowledge, some top-down knowledge, right? I mean, you cannot have the same deep network for iris, fingerprint, and face. You still have to incorporate some knowledge about what are you trying to recognize in order to build the deep network. So interestingly, for the fingerprints, as I mentioned to you, for over 100 years, we have been using these minutia points where we have the circles denote ridge endings or ridge bifurcation. So these black lines are ridges, and where they suddenly end, that's a salient point or called a minutia. And where a ridge comes and then bifurcates into two, that's another salient point. So in a typical law enforcement type rolled print, there are about 100 such points. And given two images which we want to compare, we simply find the point correspondence between the two images. Okay, this is just like stereo correspondence in computer vision. You have left image, right image, and then you find the correspondence and then estimate the depth. Same thing here. We just find how many minutiae can correspond between left image and the right image, and then more the number of minutiae which are in correspondence, higher the similarity. So we said that, well, can we take advantage of the deep networks to find an alternate representation of the fingerprints? And so this is where we designed a network. My former student, Josh Engelsma, postdoc Kai, and myself, and we found a fixed length fingerprint representation. And the reason why fixed length representation is better than minutia, because the number of minutia changes from one image to the other. Even the multiple impressions of the same finger will have different minutia. So you have a variable length representation, and that makes it difficult to do encryption. That makes it difficult to do the comparison. And now, if we have been able to find a 192-dimensional embedding, which is fixed, and once you have a fixed embedding, it's much easier to compute the similarity. right? It's extremely fast. We can do 10 million comparisons on a desktop using this 192-dimensional embedding. And then I want to show you that for solving a given problem, there is an advantage in combining multiple representation. This idea has been around for a long time. In fact, Marvin Minsky called it the society of models. You have multiple models, and combining or fusing these models gives you a better prediction. So in this particular case, we designed a two-stage search for fingerprint. Suppose the database is 50 million or 100 million. That is, the gallery size is very, very large. We use our deep print search to find a candidate list of 10,000 or so. And then we use the commercial off-the-shelf matcher, which are traditionally based on minutia, to update the rankings. And the best company in fingerprint and face recognition is NEC, and they licensed this algorithm because the minutia matcher is accurate, slightly more accurate than deep print. Because if deep print is not accurate, then the filtering will be wrong. So it has to be of the same ballpark figure as the COTS matcher recognition performance. But it is about 4 or 5 times faster than the COTS matcher. And so there was a huge interest in the commercial sector about this. So we get top K candidates and do this. And we showed for one, of course, we don't have access to 100 million fingerprints, but for 1 million database, we showed that we could improve the ranking from 99.45 to 99.48. Now, for academic purposes, you may say, well, 0.3% is not a big deal. But if you're talking about 10, 50 million, 100 million candidate, a gallery size, then this 0.3% is quite significant in terms of who will be in terms of the false positives and the false negatives. So now, another message which I want to convey to you is that biometrics is all about applications. That I'm not saying that biometrics is not about research, but doing research in biometrics without applications in mind is not a very good idea. So here, my former student, Karthik Nandakumar, he's now a professor at Mohammed bin Zayed University of Artificial Intelligence in Abu Dhabi. And that university has now close ties with Weizmann Institute in Israel. And so he had something similar what I have written down here for the artificial intelligence. So I asked him if I can adopt it, and he said yes. So biometrics doesn't start with data and end with models and predictions. Rather, it starts with a problem faced by a real world entity and ends with an action having an impact on that entity. And I think this is important to keep in mind because, what is the speed of your algorithm? What is the robustness of your algorithm? These are all very important issues which we must keep in mind when we design a recognition system. Designing a biometric recognition system in isolation, in my opinion, is not a good idea. And I think that's where, as Arun said, our research is more grounded into applications. And that's the reason why vendors often come to us and license our algorithms or so on. So here are some of the applications which I just wanted to share with you. This is on the upper left is the Hong Kong ID card, which has 2 thumbprints. And this came out in about 2000 or so, early 2000. And of course, it's the size of the population size in Hong Kong is about the same in Israel, 7 to 10 million. And, this was one of the early smart card, biometric enabled smart card. The next one is Amazon's new palm print system. I'll talk more about it. The second in the first column. Second one is a palm print system, contactless palm print system in Brazil, United Arab Emirates, iris recognition system. At the bottom is the entry-exit system at the US airports based on face recognition. Disney World Recognition System came out in 2005, which is simply not related to security per se, but it's related to financial loss, which the Disney was encountering because the ticket to Disney is like good for one day, or for the whole, you can buy a more expensive season pass for the whole year. And then people were sharing the ticket. Okay, I mean, they'll go to the park for half a day, get tired, so get out and sell it at a discount price to outside. And Disney was losing money. So now you take a ticket and insert in the turnstile, and you put your finger on the fingerprint reader, Lumidime, made by Lumidime, and then the fingerprint gets linked with that ticket, or the ticket gets linked with that fingerprint. So next time anybody wants to use that ticket, it expects the same fingerprint. I mean, it's a very nice system, but what you need to see why applications are important is there's nobody telling people what to do. They simply look at what the person in the front is doing and you just follow. So the system has to be very, very user-friendly, intuitive. It should work under all conditions, whether it's damp outside or hot and dry, and people's finger may be greasy or they applied a lotion. So that's where they use the multispectral fingerprint reader, which will not only look at the ridge pattern on the surface, but also a little bit beneath the finger skin. On the bottom right corner, there's an iris recognition system from Tan Tianyu's group, which is used in coal mines where, face with all kinds of black suit is not appropriate. The workers' hands are dirty, so they use an iris recognition system. And it's quite useful in situations when there is an accident in a coal mine. They want to know who went inside and who's still there, who came out. So this kind of a use case is very important. The smart credit card with biometrics, or what is called match on card, is available, but I'm not sure about its usability yet. It's not clear who would pay for the card. Would the merchant pay for the card, bank will pay for the card, or the customer will pay for the card? I mean, it's more expensive than just presenting your finger. So, so if you look at these applications, the three most popular biometric traits is fingerprint, iris, and face. Okay. And anytime you want to come up with, I'm not saying that other biometric traits are not useful, but I'm just simply pointing out that maybe 95% of the biometric systems deployed utilize one of these three traits. And the reason why we have more confidence in these traits, first of all, is all these three traits have shown high accuracy, both for one-to-one and one-to-many in NIST evaluations. And there's a large legacy database available. So if you want to use another biometric trait, you have to make a case about it, why these three are not adequate. So if biometrics is about application, or biometrics and applications are intertwined, then we must understand the application requirements. So what are the requirements? We can put them as, is it just doing authentication or identification? In fact, even if you are just doing authentication at an enrollment time, you also have to do what is called the deduplication or identification. Is this person already registered in the database under maybe a different name and so on? So we always require one-to-N. The question is, do we require one-to-N at both enrollment and also at recognition phase? Is the system attended or unattended mode of operation? What does it mean? Is there an attendant there or so, for example, in the case of Disney, it's an unattended system. There's nobody there telling you what to do. Is it contact or contactless acquisition? Contactless has become more important now. You don't want to touch a surface. Typically, most systems were contact, but face is a contactless system. Iris is a contactless system. What is the desired accuracy of the system? The application dictates what accuracy is needed, because if the accuracy is not up to their mark, it may not be accurate. It may not be desirable. And that's the last point, return on investment. The required throughput, that is how much time to authenticate. So in the case of Disney, I remember very well because I was involved in some discussions with the designer of the system. They measured how much time it takes for the system without the biometrics. It was, I think, something like 10 seconds per customer. And they wanted something very close to that when the biometrics was involved. And if I remember correctly, I think they settled at 12 or 13 seconds per transaction. So this is also an important issue. There should be a guarantee of system security, user privacy, robust to user behavior. A user who has never seen a biometric system, can do some unexpected things. And how will the system behave in those situations? The module integration. So biometrics is just part of an overall system. It's a small part. So if you look at Touch ID, Face ID in the iPhone, so Touch ID is just about $1 per phone. The whole hardware and software for Touch ID, fingerprint recognition system, is about $1. Now, some of the new ones which are under the screen are maybe little more expensive, about $2. As you know, most phones now have gotten rid of the bezel, so there is no home button. So there is no place to put the fingerprint. So you have to put it under the screen. And that technology is a little bit more expensive. Face ID is more expensive, and because Apple has been using the 3D range sensor, and that is why, that's it. By the way, that 3D sensor was an Israeli company, which was acquired by Apple, and that was the same sensor which was used in Microsoft's Kinect. And so Face ID is more expensive, maybe $5. And so no other, well, there are very few companies which are making Face ID. Most of them, at least for the cheaper phones, they're using fingerprint under the screen. Any questions on this? I have a feeling you guys are all experts, so I'm not saying anything new. So you may not have seen both, well, many of you may have seen the Clear system. This is an attended contactless identification using iris. And you see at most of the major airports, including Detroit. So in some sense, this is similar to the first iris recognition system at Amsterdam Schiphol Airport. But now it is quite popular. It's a Clear is now a company which is traded on the New York Stock Exchange. And it is, what is most important, it is one-to-N search. That is, you don't have to present any token, simply present your eye, and it searches the iris database of all the enrolled users, and it tells who you are. So this is an annual fee. There's an annual fee for it. I don't know how much, maybe $150 to $200 for this program, and I'm sure they bundled some other benefits into it. But it's growing in popularity. I remember at Detroit Airport when it first was introduced, there were not too many people, and now there's a small queue there as well. So it basically lets you pass through the security faster. The second system is relatively new. It's by Amazon. It was started a year and a half ago. First deployment was a year and a half ago. And it is a contactless palm print and palm vein. So it's a fusion of two modalities, palm print and palm vein. And so basically it is a unattended contact. Again, this is a identification system one to end. So you don't have to present any cell phone or any kind of loyalty card or anything. You simply present your palm. And there are multiple, it's very interesting. I'm not trying to criticize Amazon, but it sort of made life difficult for the brick and mortar stores by ordering everything. You can order everything online. And now it is opening up the physical stores, so it bought Whole Foods, which I think there are about 3,000 Whole Foods in the country. I think they have opened these stores called Amazon Go, which are small convenience stores where there's nobody in the store, no store employees there. You pick up the items from the shelf, and there are multiple cameras, and so the system knows what you picked up. It knows how much it costs, and then you simply, to enter the store, you simply present your palm, so it knows who you are, because at the enrollment time, which is a separate kiosk, you provided your palm and the credit card number and your mobile phone number, and so then you just walk out. So that's why it's also called just walk out technology. You walk out and then you get a message saying, well, you purchased $2 worth of food or something. And the system works very well. I mean, so this is going to become more and more popular. And I think this is the first kind of a system in consumer facing application. And as you know, consumers can have all kinds of behavior in an unexpected situation. So the system has to be robust. And the problem with the contactless acquisition is that how you present the palm. You could fold the palm, you can raise it very high, keep it very close to the sensor, and so on. So that is why I said that if we just do the research on somebody collected a palm print data, by having students come to the lab, and then you build a system and you say, well, my accuracy now is 99.8%, whereas the previous best accuracy, state of the art, SOTA, was 98.5, and your paper will be accepted. But then you would not know until you actually collect the data in operational setting. You would not know what are some of the challenges which you're going to encounter. So now, I think many of you know that India has the world's largest biometric system, but people don't appreciate it, what a major challenge or what a major accomplishment this is, and how smoothly it is functioning. And I appreciate it because I was involved in this project since its inception in 1998. So it's been going on for about 13 or 14 years. And I'm still involved in this project at a marginal level. So first of all, there is in order to distinguish or establish individuality of biometrics for 1.5 billion people, or India's population is about 1.4 billion, let's say. No single modality can work. So that's why they take all 10 fingerprints, face image, and the 2 iris image. So the system is a multimodal system involving 10 fingerprints, 2 irises, and 1 face image. And so what happens, by the way, you don't have to be an Indian citizen to get this 12-digit unique ID number. And this 12-digit unique ID number does not have any information about you, nothing about your age, demographics, or anything else. It's a randomly generated 12-digit number. And it doesn't require any documentation. If you don't have a birth certificate, fine. You just sort of bring somebody, say, yeah, I know this guy. If you live under the bridge, you don't have a permanent address, you just bring somebody, they call it introducer, who will say, yeah, I can vouch for it. He sleeps outside this department store after it closes every night. Things like that. They don't want to deny you this. And if if any one of you are going on a sabbatical or working for the, let's just say, Israeli embassy there, and you are there for more than 6 months, you are entitled to have not entitled, but you can apply for this 12-digit Aadhaar number, because it is useful for getting some government transactions like opening, like getting a SIM card or passport or things like that, tax filing, taxes. So just imagine the deduplication process. So if Professor Orr goes to India and stays there for 6 months, and he said, well, I need an Aadhaar program. You just walk into any bank, or earlier there used to be a specific centers. Now you can walk into a lot more places and say, I need an Aadhaar. They say, fine. You just sort of show who you are, somehow convince them, and using either your passport or your introducer, somebody goes with you, and they will take all your biometrics, your mobile number, your gender, or whatever, that's it. And then they say, okay, we'll contact you in 2 weeks or so, or 1 month. And then they will only, no metadata, only your biometrics will be used into the server in Bangalore, and they will do the search against 1.5 billion already in the gallery, already enrolled. And then if they don't find you, they will send you a 12-digit number. And then what do you do with it? Well, if you are in some subsidy, you go to the store, the person will look at your 12-digit number, and you present one finger. So at the enrollment time, they take multiple biometrics, but at the authentication time, they just take one finger. And this has been working pretty smoothly, unless your fingerprint happens to be of really, really bad quality, and that does cause problem in villages. In that case, they have an alternate finger, and now they have started taking face image for authentication. But the number of authentications they do every day is about 50 million. And you can check these statistics on the Aadhaar dashboard on the website of Aadhaar, where they post month by month, day by day, what is the number of authentications and so on. So it's an amazing system. People like it. So that's where the user acceptance of a biometric system is very important. Can you hear me? Hello? Can anybody hear me?
Yeah, we can hear you, Dr. Jain.
Oh, okay. Because everybody was quiet. Any questions? We have to enter.
Any questions from the audience?
Yes, I do.
Okay,
hi.
please.
Hi, everybody. I'm Indu Joshi. I'm a postdoctoral researcher at INRIA, Sofia Antipolis. So, Professor Jain, I have a question regarding introducing domain knowledge into any biometric system, let's say. So I primarily work in fingerprints. So my question to you is, I'm sure you must be aware of self-supervision based methods. So I just wonder whether if we introduce some kind of self-supervised task, let's say for computer vision, general, natural images, we have tasks like image rotation prediction or in painting and others. So I wonder, do you think that introducing domain specific tasks, so for instance, for fingerprints, let's say we can have tasks such as orientation estimation, or maybe counting the number of minutiae. Do you think those could be interesting tasks which can really introduce some kind of, domain knowledge? And do you have any more suggestions? Like, these are two things which I could think of. So do you think if we have to use some sort of self-supervision task so as to use the kind of handcrafted features which are generally used, and use those as the ground truth to pre-train a model? So if you can suggest something, then that would be really helpful.
Sure. This is not the venue to make too many suggestions, but I will tell you this, that in our fingerprint embedding or representation using deep networks, we did introduce minutiae. So the 192 dimensional embedding, which we get, it's a 96, 96 components are the texture components, and the other 96 are the minutia components. So that's what I meant by domain knowledge. We have both the handcrafted features as well as data-driven features, and it's the combination of the two which gives the power. I think in the case of face, for example, you could take facial components and extract some high-level features from the facial component. So you could have a network just for the mouth, a network for the eyes, network for the nose, and those could be the whole face augmented. Whole face embedding could be augmented with these component embeddings, as an example. So that's what I mean by integrating domain knowledge into the data-driven embeddings you get. We did the same thing for fingerprint spoof detection, where we took instead of taking the texture characteristics of the live images and bona fide images versus the presentation attack images, taking the whole image, we took small regions around the minutia points. And I think that has resulted in a state-of-the-art fingerprint spoof detection algorithm. We did the same thing for face spoof detection. Instead of just taking the global image, we took some local windows along with the global window and combined them. So that's what I mean. Okay. All right.
Dr. Jain, there's one more question.
Yes.
I'll read it out. And then there's another question which will come on mic. The one on the chat box. Have there been any significant problems that came from implementing the Aadhaar cards? For example, has frequency of people trying to impersonate others increased?
Right. So one of the, media always tries to cover some cases like, so many Aadhaar numbers were leaked. That is, somebody disclosed the Aadhaar number, or somebody stole somebody's Aadhaar number. The point is, it is a two-factor authentication. It is not a one-factor authentication. If I get to know Arun's Aadhaar number, it's useless, because the only time I can use it is when I present Arun's finger along with that Aadhaar number. So just knowing the number is not enough. You have to have the biometric as well as the Aadhaar number. Now, most of the authentication scenarios in the case of Aadhaar are attended applications, where either you go to the bank to collect your pension, or you go to a shop to collect your food subsidy or natural gas subsidy, or you go to a store to get a SIM card. There are some attendance systems as well based on Aadhaar, but most of the time Aadhaar system is attended. So I think impersonating somebody is extremely difficult. Of course, there may have been cases about somebody, I steal Arun's Aadhaar number, 12-digit number, then I also steal his fingerprint and then make a fake fingerprint. But we have provided Aadhaar our spoof detector, which is fairly good. So I think the chances of that happening is very small. So I think the only problem Aadhaar has the main problem Aadhaar has encountered, which caused some challenges, is the poor quality fingerprints. And that, I think now that's why they have started taking face. There is another thing I would like to mention, is that Aadhaar does not belong to any agency like Department of Ministry of Finance or Ministry of Defense or Ministry of Homeland Security. It is a separate entity which is called UID Ai, Unique Identification Authority of India. And the reason for establishing as a separate entity is that the job of UID Ai is simply to issue a 12-digit number and sort of give a guarantee that this 12-digit number belongs to Arun Ross and to nobody else. okay? And then any other government agency can build a system, authentication system or biometric system using Aadhaar central server and its facilities in Bangalore. So Aadhaar is not, this agency UID AI is not an application-driven agency. It is simply giving a 12-digit, enrolling people, ensuring that they are not already in the system and giving them a 12-digit number. And then anybody else can do whatever they want. The other important thing is Aadhaar data is never shared with anybody in the government. That is, this is stored in the server in Bangalore. Police cannot access it, defense cannot access it, passport agency cannot access it. If I apply for a passport in India and I go give my fingerprint and my 12-digit number, what they will do is send the 12-digit number and the fingerprint to the Aadhaar server to say, I want to know if this fingerprint is linked to this particular 12-digit Aadhaar number. And the response from the Aadhaar number will simply be yes or no. That's all. So once the data gets into the biometric data gets into the server, it never leaves.
And Dr. Jain?
Yes.
You must have answered this. You may have answered this already, but the question is from Tiago. How robust is the system against adversarial attacks? Any study on that?
Well, I mean, there has been a study, it's not in public domain. So, but I mean, you know, adversarial attacks is something that you can get inside the system somehow. And I think the way the Aadhaar has been designed is that as soon as the data is collected, it is encrypted and everything is sent on the secure encrypted thing to the Aadhaar server. So to inject adversarial or to launch an adversarial attack against this is, to my knowledge, or my limited expertise, is extremely difficult. It's not that it can never be done. So I think the adversarial attacks in the biometric domain, which I would call them as more of a digital attacks as opposed to physical spoof attacks, are not as critical. I think for biometrics, we are more concerned about the physical attacks rather than the adversarial attacks. Of course, one can always have an insider attack to launch an adversarial attack, but in general, now it may change when you start doing remote authentication. So for example, I want to open a bank account, I want to open a credit card, and now many of the credit card companies are saying, well, you can enroll from your home, self-enrollment. So there may be some possibility that some adversarial attack could be launched there. But I think in the case of biometric system like Aadhaar, such an attack is unlikely. Maybe I'm wrong, but that's my opinion.
Dr. Jain, we have a question from Roy, and Roy,
Yes.
feel free to open the microphone, Roy.
Okay.
Yes. You mentioned that the project was incepted in the late 90s.
No, I think. Sorry, I should say not late 90s. 2008.
Okay.
Yeah.
Okay. 2008.
Yeah.
And back then in 2008, the performance of algorithms was inferior to their performance today, and I guess that therefore 3 different modalities were chosen, and fingerprints were chosen with a 10 print.
Yes.
Have there been, do you know maybe if there have been discussions since then, it's 15 years already, to change the modalities or to drop some of the modalities, and what are the considerations behind that?
You know, it's, 25 million babies are born in India. That's like three Israels, are born in India every year. So changing the ecosystem, unless there is a good reason, it just does not make sense. right? I mean, you cannot expect to re-enroll 1.5 billion people. It's crazy. So there is no reason why iris, face, or fingerprint should be replaced by anything. Now, to your answer about using a subset of it, well, again, I think that the system was designed so that everybody is able to enroll, whether they are missing their hands, missing their eyes. Of course, face is always there. But so I think considering that you are dealing with such a diverse population and such a different economic variations, status of the people, I think it was just, I don't think it will change. Now, in terms of you have a good question about the accuracy of the system. And again, people do not appreciate what Aadhaar did to make sure that the technology remains state of the art. So for example, let's just assume that the government agency, let's say FBI, buys a fingerprint system from company A. And it's typically these acquisitions are 5-year contracts. And Roy, you are in this position where you probably are buying systems, and usually you agree to a 5-year plan to have that system. And typically you don't change the system because going to another vendor would cause more problems because you have to change the templates and everything. So there's less incentive for the vendor to keep updating the system, or but in the case of India, they said, we don't want to be sucked up by just one company and who doesn't perform very well or doesn't improve the system with time. So they said they will have 3 vendors. So they selected 3 vendors who are online at any given time. And they randomly submit the queries to all 3 vendors, 1/3, 1/3, 1/3. And every few months they do an evaluation. How are the 3 vendors doing? And the vendor which is doing better gets more load, and vendor which is doing not so well gets less load. This is not a biometric problem. This is just the way foresight on part of the Indian designers of the system to always have 3 vendors. So this way there is a competition, because if one vendor's load goes down and the payment to a vendor is based on how many queries they processed.
That's impressive.
It is.
Yeah.
Same thing for data collection. Biometrics I've been working with World Bank for biometric deployment in some of the poorest countries of the world. And one of the problems is that the system never takes off ground because the data collection is so poor. And so what India again did, first of all, they established their own standard for data collection, quality, and so on. And they did not, these are not government employees who are collecting the data. These are private contractors who are collecting the data. And they basically randomly check the quality of the data. If that data could not be enrolled into the system, the vendor doesn't get paid. So there is an incentive to the vendor to make sure that the data they are collecting is of sufficient quality that there will be no failure to enroll. Okay.
Dr. Jain, there are some questions. Did you want to go forward, or can we ask the question?
No, let's just take care of them. That's much better.
Okay. So here, Mikhail is asking that he is saying that he has heard about fraud cases, more than a few, using spoofed fingerprints.
Yeah.
They take any countermeasures, and what are your recommendations for that?
You mean for India or any place else?
Mikhail, is this for general, or are you focusing on the other program, Mikhail? Let's see if he has some clarification to his question. So Mikhail, we'll put that question on hold, and once you're able to put your microphone. Next question is, are there other modalities face or iris that are used during the recognition time in the Aadhaar project?
I think generally my feeling is, I mean, a particular agency can use anything they want. I mean, all three modalities could be used. The Aadhaar agency is simply, or UID AI is simply providing the enrollment process and a test and a platform for doing the authentication. I think the reason why iris is less popular, the sensors are more expensive. I think more effort is needed for user interaction. And so there's a little bit higher failure to enroll. And I think those are the reasons why fingerprint and face fingerprint is the most popular, and then the face.
Thank you, Dr. Jain. Another question from Sheer. Can blind individuals be recognized by their iris?
Well, I'm not sure. Arun, you are more familiar with the iris, so you may have a better perspective on that, whether what happens to the iris if somebody is blind, whether it decays or,
Yes. They have they have enrolled blind individuals, Share, so especially also John Dogman discussed that. But there are certain ailments that can preclude the iris from being used.
Right.
So,
I think so. So that's another reason why, also similar to Roy's question, that we now have 10 fingers, face, and 2 iris. Okay. So of course, the chance that everything will be missing for a person is 0. I mean, face has to be there, right? I mean, it's not that you have a headless person walking in. So if a person is missing few digits, no problem, we'll still enroll. If the person is blind, if iris cannot be captured, we will still enroll that person. So I think the India system is do not exclude anybody. Okay, that's period. Don't deny anybody the Aadhaar card. Take whatever information is available and have it available, and enroll that person.
Mikhail is offering some clarification for his questions about spoofed fingerprints. He was in fact asking about the Aadhaar program and also other parts of the world. To what extent are they taking countermeasures?
Oh, about the spoof? Yes, of course they are taking countermeasures. The question is in many of the developing countries, there is no local expertise. India was an exception because there are a lot of Indians living abroad who were doing very well. They volunteered for the system, and the system was set up by the head of the system was a person, a technocrat, Nandan Nilikani, and not typical government bureaucrat. And so that's the reason for the success. It's a question of what technology provider has given, what the vendor has given you in terms of spoof detection. And as we know, it's a cat and mouse game. I mean, you have a spoof detector, but then you come up with some new spoof type, which the system is not aware of. And sometimes you don't know whether there has been a spoof attack unless there is some other information which becomes available. So you have to constantly retrain your system. And the recent project which our lab had under Arun Ross for 5 years from Intelligence Advanced Research Project Agency, that was the goal, to build a software system for fingerprint, face, iris spoof detection, which is state of the art. And I think in that sense, we have delivered to IARPA state of the art spoof detection systems, and our approaches are in public domain. And if you want to implement it, you are welcome to implement it. But there is always going to be a constant learning of the spoof detector in the event a new type of spoof is discovered or deployed. So in our laboratory, we have 14 different types of spoof materials, what is called a presentation attack instruments, and our system is pretty robust to that. Okay, let me just start going, otherwise I may have a problem. So now I just want to talk talk about the biometrics, it's interesting. I showed this slide 20 years ago, 25 years ago, and it's still applicable, okay? I mean, so when we talk about the edge use cases, I mean systems designed to operate at the extremes of these three axes and many other axes, since I can only show three, but these are the three most important axes. Scalability, what is the size of the gallery, okay? So if you're building a national ID system for Israel, we say 10 million, or maybe 50 million just in, to encounter additional things and over time. In India case, it's 1.5 billion. In the case of FBI, maybe 200 million or 150 million. Accuracy, accuracy is very important. So whether you talk about authentication accuracy, one-to-one accuracy, and then the one-to-n accuracy is also somehow related to that. So if you want a false positive identification rate, which is very small, false negative identification rate, which is very small, then your authentication accuracy needs to keep going higher and higher. And so that's the issue there. And the third most important thing is acquisition. Constrained acquisition versus unconstrained acquisition. So that means comparing two portrait images or comparing two rolled fingerprint impressions of good quality versus unconstrained. So here is, let me just show in the case of fingerprint, I want to show you 4 different scenarios. Sorry, what happened? Okay, so this is 10 print to 10 print matching. Why do we do 10 print to 10 print matching? Well, we want to know whether a new suspect is already in the database, that is, if he has been arrested before. When I get fingerprint taken, it's often for the purpose that I'm involved in some US government committees or some studies. So they want to make sure that I don't have a prior criminal record. They take my 10 print, and FBI database may be close to 150 million, and they search against that. Okay, so again, you need a fast response and you need a very, very high accuracy. So the quality is good. NIST evaluations show that the accuracy is close to 99.99%. But this is still an important use case. In case of Michigan, anybody who deals with children, school teacher, bus drivers, daycare providers, they all have to be fingerprinted for the purpose of determining if they have a prior criminal record. This is the more common one, CSI, crime scene investigation, which you see often on TV shows. You pick up a partial fingerprint distorted with complex background, and it has to be matched with the 10 print database to identify who left the finger mark on the crime scene. In this is the scenario in the last NIST evaluation, ELFT, the rank 1 accuracy was only 67%, okay? So this ELFT stands for Evaluation of Latent Fingerprint Technology. I have heard that there'll be a new evaluation coming out this year or next year. So this is where we really need to build system. And in order to build such a system, you really need domain knowledge. You cannot build such a system just based on deep network, and I'll show you. So this is a 10 print to latent matching. That is, we arrest somebody, and now we want to match them with our collection of the latent prints, which the police maintains. And these are called cold cases. Cold cases means these crimes were not solved. So now it's possible that somebody who left the fingerprint at the crime scene was not already in the forensic database. So now they often search a new person's 10 prints, new suspect's fingerprint, 10 print, to the latent prints to solve the cold case. And then many cold cases have been solved because of this. And then we have the most difficult scenario. We take new crime scene latent and match it against the cold cases latent prints. And why do we do that? Well, for example, to find a serial killer. That is, it's the same guy repeating multiple crimes at different locations. So you can see that the complexity of the fingerprint matching is increasing from the simple use case 10 print to 10 print, which Aadhaar does. Aadhaar is not a criminal database. It doesn't deal with latent fingerprints, to this most difficult case of crime scene latent to latent from cold cases. So this, I just want to give you a sense that my research group, I'm very proud of this because we were able to build a end-to-end latent to 10-print fingerprint recognition system. So here is a query latent comes in. Everything is fully automated. That is segmentation, enhancement, feature extraction, everything is automatic, and then finally generate a candidate list, which the forensic examiner can then look at to determine which one is the correct match. So the match scores is given here. So typically, if the print is not too difficult to identify, the first match score will be very high. And after that, in this case, 290, and other match scores will be small. So what we were proud of is that we took a state-of-the-art latent fingerprint recognition system, and we fused it with our system, and rank 1 performance jumped from 68 to 71%, which is quite good. So in these kinds of problems, building an end-to-end system, it's more than deep network. You have to have a good knowledge of the fingerprint domain. So now there's another interesting line of research which is going on, which I hope some of you will consider. There is a lack of public domain database, and as we talk more and more about privacy, this thing is getting more and more difficult. So the largest open fingerprint database is NIST SD302, which is also referred to as nail to nail, which has only 2,000 unique fingers and 25,000 images. Okay, that's pretty small. I mean, you can train a deep network using that. Fortunately, we sort of had the other databases from NIST, which now they have taken it down. So the folks who have been working in fingerprints sometimes have slight advantage. I mean, that's another thing. If you're doing biometrics research and you don't have access to data, that's tough. So we said, can we generate realistic looking fingerprint images? So we built a system, PrintScan, which generates realistic fingerprints. Not only that, it can generate multiple impressions per finger, just like for face images. You need multiple impressions of the same face identity in order to train a system. And we made sure that these synthetic fingerprints don't leak the identity of the training data. And what we showed is a model trained with nail to nail, which is the only public domain database, plus 100,000 images, synthetic images from PrintScan, outperformed a model just trained on nail to nail from 73% to 87%. So what this shows is that there is a room for utilizing synthetic fingerprints to augment the real fingerprints to train a network. And I think this also has been of interest to major vendors, and they are licensing this algorithm. So here, just to test, I mean, here I've shown you this collage of 8 images. Some are real, some are synthetic. I'll give you 20 seconds to just stare at them and see if you can tell which is real and which is synthetic. And then I'll show you the answer in a second. So one with the green squares are the real images, and the one without the green square are the synthetic images. And we did other statistics, the quality measure, the number of minutiae. We did the experiments with fingerprint researchers to see if they can tell the difference, and see if like the quality or the realism of these synthetic fingerprints is pretty good. We also did something similar called Spoof GAN. That is, we can generate synthetic spoof images. And by augmenting real spoof images with the synthetic spoof images, we are able to improve the performance. And what I'm showing here in this three-dimensional representation of the embeddings is that the synthetic spoof and the real spoofs are falling together. That's the yellow and the orange region, and the synthetic live and real live, the purple and the blue, are falling in one part of the space. So these papers are available on arXiv, and you're welcome to get the details from there. Now, in the remaining 10 minutes, do I have 10 minutes, Arun?
We'd like
5
to
minutes.
have some time. Yeah, 5 minutes. Yeah.
Okay, so I want to just show about the face search, because that's, again, more challenging problem. We have a probe and we have a gallery, and we want to find the mate. And it's important that all practical problems are open set. There is no way you can guarantee that probe, the mate of probe, will be in the gallery. So let's just forget about closed set. We'll just talk about the open set. So here is the problem. This is the games magazine, which I used to subscribe to. So this is, I think, 20 years ago, 25 years ago, this appeared, but I like it. Here is the problem of face recognition. I mean, here you have Yul Brynner, who is running in this marathon, and then we have some old faces of Yul Brynner, and can we match it? That's the challenge. And we can make this problem as difficult as we want by making the probe very difficult and making the gallery very difficult. So first, this is my postdoc, former postdoc Kai. And so I asked him, hey, can you provide me with all the age face images from ID cards or just so on? And he provided. And so there's a difference of what, about 22 years or so, 23 years. And if we take the 1999 photo as gallery, state-of-the-art face recognition system has no problem except when he's wearing a mask. So all these scores are above the threshold of 0.345. So face recognition, if it is frontal pose and no expression change, some slight variations in illumination, it works. This was not the case 10 years ago, where 20-year age gap may be considered as a serious problem. So now, if you want to do unconstrained face recognition, there is a database called IJBS surveillance, which was collected by under IARPA program. So here I'm showing you, so this is the surveillance to still scenario. That is, the probe is surveillance frames of different quality, easy, medium, hard. But the gallery is a still frontal portrait images. So in the case of easy, we have 4 frames as input, and the subject is identified at rank 1. With medium difficulty, the subject is identified at rank 3. And for hard, the true mate appears at rank 38. So we are making progress, but hard cases are still hard. Now, this is more difficult scenario, surveillance to surveillance. That is video frames to video frames. We have one collection of video frames, we have another collection of video frames. Can we match them? By the way, these results look impressive, but the gallery size is very small, only 100. And that's not a very practical scenario, but this is just for illustration purposes. Now, how many of you have heard of a company called Clearview Ai? Anybody who has not heard of it? If not, you can check it on the internet. Anyway, some people like this company very much. Some people hate this company. Why do they hate it? Because what is the correct word? It hijacked 20 billion face images from various sites like LinkedIn and Facebook and so on. So, about a month ago, they called me and they said, Anil Jain, we know you and we have followed your work. I mean, I don't know what was the reason, but it was just sort of an introduction, And so when I was preparing for this talk, I said, well, since I'm talking about the edge cases, I will call them and say, hey, if I send you some queries, can you give me the retrieval? So they said, okay. So they checked with their legal department and they said, as long as the probe and the retrievals are only your face image, no problem, you can show it. So that's why I'm showing you. So I just went, my student took my photo in the courtyard of our engineering building. I was wearing a hat and it's a profile view, and it had no problem. It found these top 12 images of me. I don't know where these images came from, but there must be some place on the website, and they retrieved it. And the gallery size is 20 billion face images. This is not 20 billion unique face identities. They don't know how many unique identities there are, or maybe they know, but they're not telling me. I would suspect at least 1 billion, close to 1 billion unique identities. Then I gave them, I don't know. Arun, can you tell if the probe is me or somebody else?
Was this your Ohio State party days?
That's right. That's right. During my party days. Actually, I'm driving a boat here. They just cropped it, So, so this is my 1970 image. So it's like more than 50. It's more than 50 years old, and they retrieved these two top retrievals. Okay. So now, finally, just to say, face recognition has been under a lot of notoriety because, people, they talk about these demographic bias and so on. But I think part of that is incorrect. I mean, it's really not the fault of the face recognition. It will all mean whether that similarity makes sense or not. So what happened was in downtown Detroit, there is a watch store called Shinola Watch Store. And this guy on the left shown here is Mr. Williams. And the store had a robbery. And as you can see, the surveillance frame from the robbery is of very poor quality. And the Michigan police matched that. City of Detroit sent this to Michigan State Police, who matched that poor quality surveillance photo to Mr. Williams' driver license photo, okay? And the procedure is that a forensic examiner was supposed to examine the two faces and determine whether it is indeed a good match or not. They didn't do that. Instead, they went to Mr. Williams' house, who lived in a suburb of Detroit, and arrested him. And the poor guy said, hey, I didn't leave my house. But they put him incarcerated him for 24 hours, and then finally they released him. So the point is that all biometric systems will make errors. The question is, what are the consequences of that? And that, as researchers, we need to be very, very understanding of that, and we need to be aware of this, that we design an algorithm which behaves incorrectly in some situation, it will have some serious consequences. So just to summarize, in my opinion, biometrics is intertwined with applications, and these applications are going to grow. The system requirements are application dependent, so what we design should meet the requirements of some system. And there are a number of challenges which I have highlighted, and I mentioned about the consequences of incorrect decision. So with that, I will stop. And I know the time is almost over, but if there are one or two questions, I can answer. But please feel free to send me an email if you have any questions, and I'll be happy to answer them. Thank you very much.
Thank you very much, Dr. Jain. We can give a virtual applause, and then there are a couple of questions that are here.
Okay.
So maybe I can get to the questions. One question from Indu. As Professor Jain mentioned, there is a perception that biometrics, especially fingerprints and iris, are solved problems. What are some interesting and emerging research directions for biometric researchers so that both good publication forums and funding sources can be targeted?
Indu, that's a conversation over beer. So when I come to Switzerland, we can sit down and chat. I think I won't be able to answer that in a in a few minutes in a short time. But I hope that at least some of the problems I have large scale search, unconstrained acquisition. So in the case of iris, unconstrained acquisitions probably is the one of the more challenging problems.
And I must mention, Dr. Jain, if you go to Switzerland, you'll be missing her by a country. She's in France.
Oh, sorry, I meant France.
We next have a question from Shir. Are better image resolutions always associated with improved recognition accuracy, or does there exist a threshold?
Not really. I think we've studied this problem in the context of fingerprints, whether 1000 PPI gives a better recognition accuracy than 500. And under a couple of different projects, we were able to say that there was no significant improvement in fingerprint recognition accuracy. 1000 PPI scanners are still very expensive for fingerprints, so it's not worth it. I think same thing would apply in the case of face. There is sort of acceptable IPD, interpupillary distance, at which you get a good accuracy. Going too much beyond that may not be essential.
Thank you. Another question from Morgan. Professor Jain, what are your thoughts about the future directions of the speech modality or speech as a biometric?
I think speech is already being used in some niche applications where, authentication is done over the telephone. But, in terms of the conversational speech in a noisy environment, things are becoming challenging, and speech perhaps is easier to mimic. So, one has to find the application where speech may be the natural modality, but its accuracy may not be at the same level as face, fingerprint, and iris. And speech modality has been going on for a long time. I remember going to Texas Instruments and TI Lab, Doddington in 1975 or 76. So work has been going on, progress has been made, but it's not a general purpose solution.
Thank you. We have a question from Tiago. In your opinion, what type of properties would you think are mandatory to achieve transparent biometric systems?
So I don't, what is meant by transparent?
Tiago, are you referring to explainable biometrics? Feel free to post the question yourself, Tiago.
Hi, yes.
Hi.
So thank you, Professor, for your nice presentation. So I'm currently studying some kind of explainable artificial intelligence applied to biometrics. And we have been wondering also with Professor Aaron Ross, some of the properties that these systems should let's say, respect, so we can achieve this a kind of system that people understand. So if I'm recognized as someone who was at that time doing something, for me as a citizen, it's important that the law or any kind of other institution can explain me how they got to that decision. So how the system was, how was the system able to, let's say, output that it was actually my face there. So I'm wondering if you could know some kind of properties that we should enforce in our models to achieve.
It's a question of how you compute the similarity. Everything is about computing the similarity. So if you are using minutia, you can always say, look, and that's what the forensic examiners testify in the court, that I could match so many minutia and the rich structure here. When I overlay the two fingerprints, rich structures don't match. Information like that, which is physically interpretable. But when you use the deep features, then it becomes difficult to explain why two face images are not matching. And people are making efforts, but I don't know if there is any good way to currently explain why two faces match or do not match. Because, first of all, explaining what each individual component in the 128 dimensional embedding does, or how does it relate to a face attribute, is difficult. So maybe we can start looking at the local facial features local regions of the face, and then also say something like, well, the noses are very similar, noses are different, things like that. But I'm not aware of any off the cuff. I don't have any good suggestions.
Right. So thank you anyway, because I believe that perhaps a really nice direction would be on how should we compute that metric that you are talking about, the similarity metric. Yes. Thank you very much.
Thank you. Dr. Jain, one more question from Antitza. I think you must have asked her some questions, so now she wants to ask you some questions. At this point, should we still determine the distinguishability of biometric modalities, or is it solved as some systems perform so well?
Well, it's a question of, I think it's always an interesting question at the theoretical level, because the whole biometrics is based on distinguishability. And, it's a question of, if you want to apply for $10 million grant, and at the interview, somebody asks you, okay, and it's you're working on face recognition at 0.01% FAR, how many unique identities can you identify? What would your answer be?
She's computing it, Dr. Jain.
Yes, I'm computing it. Yeah. Yes.
So it's a natural question to ask, right?
Right.
And people don't have an answer to that.
Exactly. And it seems like we jumped over that, and we say but it's working. It's like you say, we care about the application, we care that it works,
right.
But somehow we jumped over this theoretic, which should have been the basis, right? Which should have been.
Right. That's right. And that's why I'm very proud of the work which my students did on the individuality of fingerprints and the persistence of fingerprints. They may not get I think the individuality got quite a few citations, but longitudinal study of fingerprint didn't get as many citations because, people just assume, oh, yeah, this is, but I consider them as fundamental problems. And we worked on the capacity of face recognition, but the reviewers didn't like it. So still people are intrigued that we were able to at least start addressing the capacity of face recognition. That is, if I give you FAR, how many unique identities can your system recognize? And maybe that's how we should be looking at the power of representation, face representation. If my representation can identify more identities than your representation, then in that sense, my representation is more powerful than yours. So, I consider them as fundamental problems, but at the same time, that's only a small number of people who are curious about it. And as I said, the purpose is not to criticize, but just to say that just collecting data and then building a model, that's only half the story. There's a lot more goes on when actually deploy the system.
Thank you very much, and thank you for the great talk.
Thank you. All right.
Yeah, thank you, Dr. Jain. That was excellent, and thank you all for the excellent questions and very pertinent questions. I just found out that our youngest attendee today is 5 months old. His name is Siddhant, and Sushant sent us a picture of him watching Dr. Jain's
Oh, I see. Well, he's a budding biometric researcher, man. He's curious,
Yeah, he's going to solve the distinguishability problem.
Well, hopefully, Arun, next year we will meet in person in Haifa.
That's right.
As opposed to remote lecture.
That's right. Yeah, we look forward to that and meeting.
And Antitza, I'm still waiting for your invitation to visit in person, so that we can have the real exam. That was just a fake exam.
No, the invitation holds. The invitation is anytime you want.
Okay.
Of course, you're very welcome.
All right. Thank you, everybody, for your patience. And please feel free to send me an email if you have questions.
Yeah, thank you
very much.
Yeah, thank you, everyone, for attending. All the best, and we look forward to seeing many of you in person soon.
Bye-bye. See you soon.
Bye.
Thank you very much.
Thank you.
Bye.
Thank you.
Yeah, thank you.
Yeah, good to see you all. And again, if you have any questions, feel free to send emails, and Dr. Jain will be happy to correspond. Roy, I think you're saying something, but you might be on mute. Sorry.
I just wanted to say thanks so much once again.
Yeah, thank you. Thank you. Thanks, Roy.
Thank you, Professor Jain.
And Roy, hopefully we'll see each other soon.
Hopefully.
Yeah. Good. I think we had Anna also here, but I think she just left. Okay, everyone, we'll close the seminar now and talk to you soon. Bye-bye.